Okay, ladies and gentlemen of Geometry B, we are looking at trigonometry. Trigonometry is probably one of the biggest battles that geometry kids have. So basically what we're looking at is just right triangle trig, and we're looking at this because these ratios, these trigonometric ratios, work for every single right triangle. Okay, so if you have a very specific one, they're going to work every single time. So trig comes from the word trigon and metron, which means triangle measure. So a trig ratio is a ratio of lengths of two sides of a right triangle. Any triangles that have two angles that are congruent are similar. Therefore, there's certain ratios that can be used for all right triangles. So now, double check in your calculator. Make sure that in your calculator you are in degree mode, because if you're not, you're going to get wrong answers all over the place. So degree mode. So check, and if you get sine of 24 and it's not, if you get sine of 24 and it's not this, you did it wrong. So make sure you are in degree mode. So look at the words. So, ka, toa. That is pretty much the big word that you need. Is that sine of is opposite over hypotenuse. Now you're looking at from the perspective of the angle. So if I'm looking at A, opposite over hypotenuse. Hypotenuse is always hypotenuse is always hypotenuse. So that's going to be A over C. Cosine is going to be adjacent over hypotenuse. Adjacent just means next to. So adjacent to angle A is going to be B, and then the hypotenuse, so that's going to be B over C. Tangent, no hypotenuse needed, so that's going to be opposite over adjacent, so that's going to be A over B. Now, looking at it from the perspective of B, so let's look. So sine of B. So from the perspective of this angle, you can even put your pencil or pen on this angle to kind of look. What's opposite of this angle? Well, B. The hypotenuse is always the hypotenuse. So that's going to be C. So for cosine, that's going to be adjacent. So that's going to be A. Hypotenuse is always hypotenuse is always hypotenuse, C. And then lastly, tangent of B, opposite over adjacent, is going to be B over A. So you're always looking at the relationship from an angle. So express each trig ratio as a fraction, and then as a decimal to the nearest hundredth. So that's 2 decimal places. So sine of J, so J is here, opposite over hypotenuse. So that's going to be 5 over 13. So as a decimal, that's 0.38. Cosine of J is adjacent, so next to and hypotenuse. So that's going to be 12 over 13. So that's going to be 0.92. Tangent of J is going to be opposite over adjacent. So 5 over 12. So that's going to be 0.42, rounded. Okay, so now, for this one, look at everything from the perspective of K. All right, so K is right here, so I'm looking at everything from this perspective. So the opposite from K is going to be 12 over 13. Adjacent is going to be 5 to 13. And tangent, opposite over adjacent, is going to be 12 over 5. So 12 out of 13, that's 0.92. 5 out of 13 is 0.38. 12 over 5 is going to be 2.4. So figure out the sine of L, cosine of L, and tangent of L. So sine of L, remember sine, so opposite over hypotenuse, from L. So opposite is going to be 2 square root of 3. A hypotenuse is going to be 2 square root of 15. Now, if you leave it like this is wrong. So you need to simplify it. By doing that, you need to multiply both the top and bottom by square root of 15 over square root of 15. So these 2's end up canceling out. So what you're left with is square root of 45 over 15. Now, simplify the square root of 45. Don't get lazy. Don't get lazy. So square root of 45 is going to be 9 and 5, so that's going to be 3 square root of 5 over 15. So that's going to be square root of 5 over 5. So that's your sine, square root of 5 over 5. Now, cosine. Cosine of L, adjacent over that. Adjacent over hypotenuse. So that's going to be 4 square root of 3 over 2 square root of 15. So again, square root of 15 over square root of 15. Use your heads. 4 over 2 is just 2. You can start thinking about that. So now you got 2. On the top, you got square root of 45. On the bottom, you've got 15. So square root of 45, we just simplified that. So that's really 2 times 3. Let me move so I got a little room here. So let me rewrite it. Now I'll move it down here. 2 times 3 times square root of 5 over 15. So that's 6 square root of 5 over 15. Or simplify, divide by 3, 2 square root of 5 over 5. There is my cosine right there. Simplified. And yes, you do need to simplify it. Come on, don't be lazy. So tangent then becomes opposite over adjacent. So that's the TOA. So tangent becomes opposite over adjacent. So my opposite side is 2 square root of 3. Adjacent side is 4 square root of 3. This one's actually easier. Let's watch what happens. 2 square root of 3 over 4 square root of 3. Well, the 3 over 3 cancels out. 2 over 4 is 1/2. There's my answer. That's all I need. So we have sine, we have cosine, we have tangent. That's all we need. Simplified. I know it takes a little bit of work, but it's good practice. So let's take a look. A fitness trainer sets an incline at 7 degrees. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? So this is opposite. This is hypotenuse. This is hypotenuse. So look at what you're dealing with. So that's going to be tangent. No, sorry, not tangent. Blah. Not tangent. This is going to be sine is opposite over hypotenuse. So that's going to be the sine of 7 degrees is going to be equal to y over 5. Now solve this. Solve it like you normally would. If you put sine of 7 into a calculator, you will get a big, long, ugly decimal. Round it off, go to about 4 places. So that's 1217 equals y over 5. And if I just multiply that by 5, you're going to get that it's going to be 0.6093. Now that's in feet. Approximately how many inches? So if I take, this is in feet, so if I multiply it times 12, that's going to be 7.3 inches. There's my answer. But all of this comes from the setup. Which function do I use? So if I'm looking, figure out the value of x. Well, here's the angle I know. So that's the angle I want to take the perspective from. So x is the opposite. 18 ends up being the adjacent. So adjacent, opposite, means I use tangent. So that means the tangent of 25 equals x over 18. So tangent of 25, actually plug it into your calculator. You plug it in, you get 0.4663 equals x over 18. So multiply that by 18, x ends up equaling 8.394. There's my answer. Now, bottom of a handicap ramp is 15 feet from the entrance of a building. The angle of the ground is 4.8 degrees. The angle of the ramp is 4.8 degrees. About how high does the ramp rise off the ground? So we're looking for this side right here. So 4.8 degrees, this would be opposite. This would be adjacent, which means I want to use tangent. So the tangent of 4.8 equals the opposite, which I'll just call x over 15. So tangent of 4.8, pretty small number, 0.0839 equals x over 15. So multiply both sides by 15. So you get x equaling 1.26 feet. So that's how high the ramp comes off the ground. Okay, last one, figure out what x is. So kind of working backwards here. So figure out your angle. That's going to be 15 degrees. X is going to be, I'm hoping you're saying opposite to yourself because that's exactly correct. 12 is going to be my hypotenuse because a hypotenuse is always a hypotenuse is always a hypotenuse. So opposite and hypotenuse, I'm hoping you're telling yourself that is sine. If you're not sure, remember you can always write SOHCAHTOA to help you out. In fact, I would argue that would be a great idea on quizzes. So you want sine of 15 equal to x over 12. So the sine of 15, you actually put it in the calculator and you get 0.2588, and it keeps going 19 for whatever, equals x over 12. So multiply both sides by 12, and I get x equals 3.106. There's my answer. Okay, play around with that. Make sure that you are looking at everything from the perspective of the angle that's important. Make sure you know this word. Come talk to me with questions. Make sure that your calculator is in degree mode. If you're not sure how to do that, come talk to me, and we'll figure this out.